Welcome you all. We'll start the problems on lateral earth pressure, that is retaining wall. There are many problems I considered and even solved while explaining the cases. In the previous video, we made a many cases in lateral earth pressure, and there I explained a few problems. Okay, considering them, then few other problems I am going to explain in this video. Okay, look at here, the retaining wall a 4 meter high as a smooth vertical back. Okay, this is as per assumption. The data we need to assume here, we need to take here is 4 meters, very important. The backfill has a horizontal surface. Okay, in level with the top of the wall. Understood? This is uniformly, there is uniformly distributed surcharge load of 36 kilonewton per meter square. Okay, there is a uniformly distributed, means UDL, there is a surcharge. Okay, very important. The intensity over the backfill, the unit weight of the backfill is 18 kilonewton per meter cube, very important. The angle of shearing resistance 30 degree, very important. Cohesion is 0, cohesion is 0, very important, means that this is a sandy soil. Sandy soil. Determine the magnitude and point of application of active earth pressure. Okay, they are asking active earth pressure per meter length of the wall. Okay, this ignore this one. If the water table rises beyond the wall to an elevation of 1.5 meter below the top, determine the total active earth pressure and its application. Take submerged unit weight 12 kilonewton per meter cube. Assume that there is no change in the angle of shearing resistance due to submergence. Okay, the second part we will consider it later. First we will solve the first part. In the first part it is said that there is a retaining wall of 4 meter height. Right? This is a retaining wall. The height is 4 meter, and they said that the backfill as a level surface, that is a horizontal surface. This is your horizontal surface. Okay, and here the soil we have, that is a one surcharge is there. That surcharge is a Q, that is given as 36 kilonewton per meter square. 36 kilonewton per meter square surcharge is there, and some soil properties are given, density is a 18 kilonewton per meter cube. Density, dry density is a 18 kilonewton per meter cube, and we have a phi value, that is 30 degree. Phi value is 30 degree. Over this much data is given in the first half. Okay, that we will solve. What they want active earth pressure. Therefore active earth pressure means we need to calculate Ka equal to 1 minus sin phi divided by 1 plus sin phi, that is your 1 minus sin 30 divided by 1 plus sin 30. Okay, that is 0.333. Okay, Ka you got, because they are asking active, therefore we calculated Ka. Over. Now we will take one reference point here and one reference point here, A to B. Then this is my reference line. Let us call this as a A point, this is a B point. Right? Now I will calculate sigma h at A. Sigma h at A. At this point, what all the stresses are acting? Actually, this A and B point I have to consider near to the retaining wall. Okay, wherever that retaining wall is there, actually I have to consider A here and B here. Okay, here many datas are written, that's why I am considering away from the retaining wall. It doesn't mean that the stresses will be acting here, not here. No, there is a distance here, that doesn't matter. Actually I have to consider A point here, B point here. There are datas and there are some confuse that what here this area is utilized, that's why that is far away from the retaining wall. Understood? Now at point A, what all stresses are acting? At point A, there is a one surcharge, that vertical stress is acting. First I will tell you what is sigma HA. Sigma HA is what? Ka into vertical stress. Then at A, Ka into vertical stress, we have a Q, and we don't have any vertical stress due to soil. Due to soil we don't have, but due to surcharge we have a Q. Therefore this is 0.333 into 36. 36. Okay, into 36. The answer is 0.333 into 36 is 11.98 kilonewton per meter square. Okay, we got sigma h at A, then we will go sigma h at B. B point is at this point actually. This point, what all the stresses are there? Vertical stress. We'll write first Ka into vertical stress. Ka is a 0.333 into vertical stress. What is the vertical stress here? One is a Q. Q is acting at the top, means that vertical stress that is there here also, it will be, that effect will be there, and above that there is huge amount of soil is there. Therefore that is Ka into Q is also there, plus we have some soil for a height h. Therefore this is 0.333 into 36 is a one part, plus we have a 0.333 into gamma is a how much? Gamma is 18 into height is how much? 4 meter height, 4 meter. Then I will separately calculate. This is 11.98 plus how much it is? 0.333 into 18 into 4, we got 23.96 97 23.97 we got. The total, if you want, plus 11.98, the total 35.956 kilonewton per meter square. That I will mark in the diagram. Look at here. Here we have a little amount of stress, and after that it is increasing like this. Right? Now I will make here one straight line so that I can divide the entire area into rectangle and triangle. Okay. This amount is how much? Sorry, this amount is 11.98. This is 11.98, and this is also 11.98, and this one is 23.97. This is 23.97. We got this one. Means I will get one pressure here, that is your P1 acting at a distance Z1 is equal to 2 meter from the bottom, and we got one more pressure here, that is a P2 acting at a distance h by 3 from the Z2, it is h by 3 from the bottom. Now I will calculate P1 and P2. Then P1 is equal to, that is a rectangle area, therefore 11.98 into 4. Okay, this is 11.98 into 4, that is 47.92, acting at a distance Z1 equal to 2 meter, and P2, that is half into the distance 23.97 into 4 meter, 23.97 into 2, that is 47.94 kilonewton. Okay, this Z2 is 4 by 3, that is 1/3 of height, that is 4 by 3 is 1.33 meter. Okay, now the total force P will be equal to 47.92 plus 47.94. Wow, we get somewhat equal. 47.92 plus 47.94. Okay, that you are getting 95.86 kilonewton, and Z bar will be equal to P1 Z1 plus P2 Z2 divided by P1 plus P2. I will not substitute, I will just calculate and put the answer. The answer we got 1.67 meter. Means go back to the diagram. In this diagram, the total stress which is acting here is here it is acting. This is the distance is 1.67 meter, and the total weight here is how much? 95.86. The total weight is 95.86. Now come back to the problem. In this problem, the first half is over. The first half is over. The second half, it is said that if the water table rises behind the wall of an elevation 1.5 meter below the top. Therefore, this is the top. Below the top means here. Here if a water table is there, okay, then this is a 1.5 meter. If it is 1.5 meter below, will be how much? It is a 2.5 meter. Okay, if this is the case, then what is the active earth pressure they are asking? We'll draw the new diagram and we'll solve the problem, right? Now look at here, a new diagram we are going to solve. Draw. This is your retaining wall, same 4 meter height, 4 meter height, and this is your backfill. And here we have a water table. This is our water table. The water table is available at a distance 1.5 meter. Therefore, this become 2.5 meter, no doubt. Okay. And in the problem, it is said that assume that there is no change in angle of shearing resistance, means what I have to consider? The phi value I will consider 30 for this and even for 30 for this, means Ka is same 0.333. Ka is same, active earth pressure. Okay, gamma here it is given as a 18, and now this side it is given how much? Here it is given 12 kilonewton per meter cube. What is that? Submerged unit weight, means gamma dash is given directly. Gamma dash is 12 kilonewton per meter cube. Okay, this much is given. Now I will make a reference point A, and now this time I have to hold this also B, and this is a C. You already know that this will be our reference line. Then I will calculate sigma H at A is equal to Ka into vertical stress. Okay, surcharge is also there. Surcharge I forgot. No, that surcharge also I have to take here. That is your surcharge. Then again, this A point means that point is here, B point is here, and C point is here. Then on the point A, how much is the load? Vertical stress. Vertical stress is a Q. Q is how much? 36. Means I am getting same 11.92. 11.92 same 36 into 0.333, 11.99. 11.99 I got here, kilonewton per meter square at a point A. Come here and write. This is at a point A, 11.99. Okay. Now this I can mark it like a straight line. Okay. Now I want at a point B. At a point B I want. At point B I want means what I have to do? Look at it. Sigma H at point B equal to Ka into sigma V, vertical stress. Then Ka is a 0.33 and Q at that point is because of surcharge and there is a soil, dry soil, that is a gamma D for a distance H1. Okay, that I will write here 0.333 into 36 plus 0.333 into a dry soil with a unit weight 18 and that is for a distance 1.5 meter. Separately I will do this one, that is your the first answer will be 11.99 and the second answer is 0.333 into 18 into 1.5, that is 8.99. 8.99. Okay, this much I got, and the total if you want 8.99 plus 11.99 is a 20.98. 20.98 kilonewton per meter square. Okay, now this I will mark here. This I will mark here. This is over. Actually, now look at here. The very interesting thing is that this soil is there. No, this soil acts as a surcharge for the bottom soil. Therefore, I will make a straight line. That one I don't calculate this one. This is already known to me. That is this much is 11.99 and this I just now I calculated this as a how much 8.99. This is 8.99 and the total I got here 20.98. 20.98. Okay, then this rectangle is because of the top soil, its effect in the bottom. Now I have to come to the bottom soil, and the bottom soil will be, I will be drawing here, and the bottom soil diagram will be like this. And bottom soil here there is a water table. Therefore, according to that in the theory I told you that whenever the water table is given, there we need to make two things. That is one for submerged soil and another for this water. This I will be writing Ka into gamma dash into H2. Okay. That I will calculate here. That is sigma H at C point only because of submerged soil. Submerged soil, that is your Ka gamma dash into H2. That is 0.333 into gamma dash is how much? It is given 12 into H2 is how much? H2 is 2.5 meter. Okay, the answer will be 0.333 into 12 into 2.5 is a 9.99 kilonewton per meter square. This I am going to write here. This value is 9.99. Then another triangle we will be having. That another triangle will be of which one? This is because of water only, where K will not come. Therefore, I will write here sigma H at C because of water. That is your K will not come, gamma W into H2. That is 9.81 into 2.5. Okay, 9.81 into 2.5 is a 24.52. 24.52 kilonewton per meter square. That I will write here 24.92. Okay, now I got how many triangles? Look at here, how many diagrams? One rectangle here, and the second triangle here, and the big rectangle here, fourth triangle here, fifth triangle here. Okay, means that many P, capital P will come. The first capital P will be P1, and this will be P2. Okay, and this will be P3, and this will be P4, and this P5. Okay, now that I will calculate now. P1 means what? P1 is the area of the small rectangle, 11.99 into 1.5. 11.99 into 1.5, that is 11.99 into 1.5, 17.98. 17.98. Then over P2 is a small triangle, that is a small triangle, half into 8.99 into 1.5, half into 8.99 into 1.5, that is your half into 8.99 into 1.5, 6.74. 6.74 kilonewton. P2 is over. P3 is a big rectangle, that is 20.98 into 2.5. 20.98 into 2.5. In your examination, one below the other you write, so that you can fill the pages. No? Don't write like this. 20.98 into 2.5, that is 52.45. Okay, then I will calculate P4. Okay, P4 will be equal to a small, that this triangle, the first triangle, that is 9.99. Therefore half into 9.99 into 2.5, that is 9.99 into 0.5 into 2.5 is the 12.48. 12.48 kilonewton. Then P3 will be equal to half into 24.92. 24.92 into 2.5, that is 0.5 into 24.25 into 2.5, 30.33. 30.33 kilonewton. Okay, now I have to write the heights also. That is the Z1 will be, for the first one, Z1 will be from here to here. It is means half of the 2.5 plus half of the 1.5 plus 2.5, that is half of 1.5 plus 2.5. Okay, therefore that is 1.5 by 2 plus 2.5, 3.25. 3.25. And here this Z2 will be from here this height to this height, means 1/3 of 1.5 is a 0.5 plus 2.5 is a 3 meter. Okay, then Z3 value will be from this height to this height, that is 2.5 divided by 2, 1.25. Then this one will be 1/3 of 2.5. Z4 will be one third of 2.5, 0.8, and even Z5 is also 0.833. Okay, now I will add all the p values, then I will get a p, and all the z values, sorry, not all the z values, z will be equal to p1 z1 plus p2 z2 plus p3 z3 plus p4 z4 plus p5 z5 divided by this capital P you can write, or otherwise p1 plus p2 p3 p4 p5, that you can make it. The total answer will be, the total value we got here 119.98, round it up to 120 kilonewton only, and z bar we got here, just substitute and calculate, that is 1.5 meter. This got 1.5 meter. Okay, this is what your problem, you can draw that one, everything here it is already drawn, means at a 1.5 meter we are going to get this 120 kilonewton, means 1.5. This is the total answer. Over, the problem solved. We'll go to the next problem. A vertical excavation was made. This is very important problem. Now we are going to the second type of a problem, that is your cohesive soils. Cohesive soils. Cohesive soils means C will be there. C is not equal to 0 now. Okay, and even phi is also there. Now, a vertical excavation was made in a clay deposit having a weight of 20 kilonewton per meter cube, and excavation that, sorry, wait. Okay, and it caved, this is statement is very important, it caved in after the depth of digging reached 4 meter. This is very important, means it is a twist, it is, I can tell this one as a twist it is. Okay, the taking the angle of internal friction to be 0, calculate the value of cohesion. Okay, small part, the first part is given, calculate a cohesion. The second part they will come if the same clay is used as a backfill against the retaining wall up to the height of 8 meter, then here the retaining wall problem comes. This is a retaining wall problem, but the first half is not a retaining wall problem. That is just a 1 mark or 2 mark problem. It is what they said. Just look at here. There is a ground here, and they have started excavating the soil. When they excavated that soil, and when they reached a 4 meter height, then the soil start falling inside. Look at here how beautiful it is. See, they started excavating the soil, and when they reached a 4 meter from the top, then the soil fell inside. Means I can tell that up to this much the retaining wall was not required, it was standing still, but later it is fall down, means I can say that this is a H critical. H critical, that formula is 4C by gamma into tan phi. 4C by gamma into tan phi. Now this is a 4 meter they have given, and 4 means a 4. C is how much? Don't know. C is unknown. Okay, because they are telling that they are asking us to calculate cohesion only. C is unknown. Okay, and they said that angle of internal friction is 0. Angle of internal friction is 0 means, sorry, it is alpha, and alpha equal to 45 plus 5 by 2, and this is 0, therefore alpha equal to 45. Then we got into tan 45 divided by gamma is how much? Here is there any gamma information? Yes, 20 kilonewton. Then we will write here 20. Then we will get answer. This is gone, and 4 will be cancelled. Therefore C equal to 20 kilonewton per meter square. See, the first half is over. The first half is that is all about understanding the problem. The second half is there is a retaining wall here. They said that 8 meter retaining wall is there, and that backfill is filled by this type of a soil. Okay, that soil was filled, and we need to calculate what active earth pressure we need to calculate. First we will work out on the first point, and later we will go to the second point. Draw the retaining wall. This is a retaining wall, and the height is 8 meter. The height is 8 meter. Okay, and this is a C equal to 20 kilonewton per meter square, just now calculated. Phi equal to 0 soil, gamma equal to 20. These informations are given. Now this is not a sandy soil, this is not a cohesion less soil, therefore we will not calculate Ka, Kp, not like that. This is an active case given, therefore active formula we need to remember, that is sigma H for active case will be equal to sigma V into sigma V cot square alpha minus 2c cot alpha, 2c cot alpha. Then here alpha equal to 45, we got it. Therefore if I write this equation, simplify this one, sigma V minus 2c is your answer. Sigma H equal to this become. Right. Now go back, we'll make up points here, the first point, and usually our triangle will be how much, our diagram will be how much, how it will be looking. Then here the tension zone comes somewhere, it becomes 0 and later it spreads. This distance is given, this distance is how much, this distance is how much, this is a H crack or H tension zone. H tension zone usually will be equal to 2c by gamma into tan alpha. Therefore 2c by gamma, tan alpha is 1, 2 into c is a 20 and divided by gamma is also 20, therefore it is 2 meter. Therefore I can mark here ht equal to 2 meter. Any doubts? No doubts. Now below how much it is, if it is 8 meter, 2 meters gone, means it is 6 meter below. This is 6 meter below. Then this height, this distance I want. Now this point means what, it is h equal to 0 soil, h equal to 0 level. Then I will put here, where is the h here, there is no h here, I will make it, that is your gamma into h minus 2c, where h equal to 0 means sigma h equal to minus 2c, that is minus 2 into 20, that is your minus 40. Then I will write that minus 40 here, a minus 40. Right. Then coming to this end, and this end we have h equal to 8 meter. Okay, h equal to 8 meter. Then I will calculate that, that is sigma h equal to gamma h minus 2c. Therefore gamma is a 20 and h is a 8 minus 2 into 20. Therefore 20 into 8 minus 20 into 2 is a 120. This is 120. Now you can come here, this is your 120 kilonewton per meter square. This is a 40 and this is a 120, you got it. Right. Now go back to the problem. What they want, total active earth pressure, only that much they mentioned, not mentioned anything. Total active earth pressure means what, this is a negative pressure, this is a P1 and this is a positive pressure, this is a P2. That I want to calculate. Therefore P1 is equal to half into 40 into 2 meter, 2 meter. Therefore P1 is equal to minus 40. P1 I got, this is a minus 40. Then I want P2, then P2 will be equal to half into 120 into 6. Okay, now that is 6 meter, this is a 6 meter, therefore 6, 120 into 6 360. This is a P2 equal to 360. Then what is the total P? Total P will be equal to 360 minus 40, therefore 320 is your total P acting. Then where exactly this Z1 is acting? Z1 is acting, look at here, Z1 is acting, I am considering like this. This is the distance where Z1 is acting, means this, the top portion I can consider it is a 1/3 of 2 meter, and bottom portion, that is 8 minus answer. Therefore this Z1 is 8 minus 1/3 of 2, that is 2 by 3, 2 by 3, 8 minus answer is 7.33, 7.33. Then Z2 is how much? Z2 is where it is, Z2 is here, this is a 1/3 of 6 meter, that is 2 meter. Okay, then Z bar you need to calculate, that is your P1 Z1 plus P2 Z2 divided by P1 plus P2. I will not substitute, I will just calculate it. The answer is 1.33 meter. Okay, work it out and compare the results. Okay, now go back to the problem. Yes, the first one is over. The second one is total passive earth pressure assume that the wall yields enough to allow the Rankine's deformation condition to establish. Okay, means they are telling that the wall is allowed to yield enough. Okay, they are asking passive pressure. Okay, passive pressure means what? Now we need to go back to the another equation, passive equation, that is sigma h equal to sigma v tan square, this time tan square alpha plus 2c tan alpha. Okay, alpha equal to 45, therefore this will be sigma v plus 2c sigma h. Then sigma h I can write it like gamma h plus 2c, therefore gamma first layer at a, sigma h at a where h equal to 0, then that is 2c, therefore 40. Okay, one thing. And sigma h at b point at the bottom, that is your gamma h plus 2c. Gamma is how much? 20 into h, total height 8 meter, plus 2 into 40, 2 into 20, therefore this is a 160 plus 40. Then the diagram will be, the diagram I will draw here. This is 8 meter. The passive case, the diagram will be one rectangle and one triangle. Okay, and this rectangle at the top, it is a 40, therefore this is a 40 and this is 160. Calculate p1, the area of the first triangle, and the calculate p2, the area of the second triangle, first rectangle, second triangle. Z1, the half of this one, the Z2 is a 1/3 of the triangle, then Z bar you calculate, you will get the answer. We'll go to the next problem. Now the 6 meter high retaining wall, this is a 6 meter high retaining, a high vertical wall, supports a saturated pure cohesive, very important, pure cohesive backfill with horizontal surface. The top 3 meter of the backfill has a 18 kilonewton per meter cube density and 18 as a cohesion. The unit weight and apparent coefficient of the bottom 3 meter is this and this. Then calculate this. First we'll draw the diagram. No? They said that there is a 6 meter high retaining wall. There is a 6 meter high retaining wall, right? And the backfill is horizontal. That is horizontal. The first 3 meter and second 3 meter they are talking about. Therefore, this is a 3 meter and this is also 3 meter, right? Now this is a pure cohesive soil. Pure cohesive soil means C equal to, C is present, but phi equal to 0, very important. Pure cohesive soil, therefore phi equal to 0. Alpha equal to 45 plus 5 by 2, therefore alpha equal to 45. Concluded. Now go back. Here the top soil is given some property and bottom soil properties. Top soil is gamma is equal to 18 and C equal to 18 units, you just write it down. And the bottom soil gamma equal to 20, gamma equal to 20 and C equal to 24, right? Now think that you have only one type of soil. You have only one type of soil, that is, think like that, that is only 3 meter if you have. Then how the diagram will be? The diagram will be, this is a cohesive soil, therefore something, a negative will be there, and that negative will come like this and becomes 0 somewhere and it will merge. This will come now. But now whether this diagram is right or wrong, that I need to check. For that I should know at what point it is going to become 0. This is your H tension zone height. Okay, na? Then what is the formula for tension zone height? Ht equal to 2c by gamma into tan alpha. The top soil it is, therefore the C is 18 and divided by gamma there is 18 and tan 45 it is, tan 45, therefore the answer is 2 meter. Okay, 2 meter. Whether the diagram which I drawn is right or wrong, that is right, because this is a 2 meter, the total height is a 3 meter, there means 1 meter is left. Okay, the total diagram what I drawn is right one, my assumption is right one, right? Now I need to calculate this distance, that is the top soil. I'll consider this as a A point, this is a B point, and this is the C point. Now sigma h at A point will be equal to, the formula is gamma into h, or otherwise sorry, sigma v into cot square alpha minus 2c cot alpha. Okay, cot alpha is equal to 1, therefore sigma v minus 2c is my equation. Then this is a gamma h minus 2c. Then sigma h at A means that is h equal to 0, therefore minus 2c is the answer. Minus 2 into 18, therefore minus 36 is the answer. That I am going to write it here, minus 36. Correct? Then this is a 0, 2 meter is over. Now I need to calculate this one. Now this layer is there, no, this B layer, whether this B layer belongs to the top soil or bottom soil, that I don't know. Therefore I have to make a 2 layers. One is just above the B, that is sigma h. I need to calculate at B just above, okay, sigma just above. Then the formula is sigma v minus 2c. Then what is the vertical stress just above, what is the vertical stress? The vertical stress is because of this much of soil, therefore that is your gamma into h. Gamma is a 18 and h is a 3 meter soil, na? Minus 2 into which c it is. See, this the top soil means just above the B point belongs to which C? That belongs to the top C. Therefore, this is C1 minus 2 into 18. The answer is 3 times 18, 2 times 18. Therefore, 18 you got it. Means I can write here this answer is 18. But I don't know what is happened below. Below I don't know. Therefore, I will consider another point here. That point I will call it as a sigma HB. But B is what? Just below, then the formula is sigma V minus 2C. Therefore what is the sigma V here? Look at here, at this point what is the vertical stress? Vertical stress is because of this soil, again that soil only. Therefore that soil density is 18 into the distance is 3. Very important, 18 into 3 minus the below point. The just below point means this point belongs to which C? That belongs to 28, 24. 2 into 24. Therefore the answer is 18 into 3, that is 18 into 3 minus 2 into 24, that is 6. I got 6 here. Means I will write that 6 somewhere, plus 6, no, that 6 I will write somewhere here. Okay, don't worry, don't write it here, that is your 6. Okay, then I will have a fresh reference line. Then this is 6, then I will let it down, that 6 will come down. Okay, now I want at a C point. C point means only one layer is enough. Therefore I will calculate sigma h at C. That is your sigma V minus 2C. Now what is sigma V? Sigma V at C is what? Sigma V at C is because of vertical stress at C will be because of this soil plus because of this soil. Two soils are there above C. Therefore that is your gamma 1 H1 plus gamma 2 H2 minus 2C. C is belongs to what? Now this C points, the C points belongs to the second soil. Therefore second soil C value is 24. Therefore this is C2. Now I will write it 18 into 3 plus 20 into 3 minus 2 into 24. The answer will be 18 into 3 plus 20 into 3 minus 2 into 24. The answer is 66. 66 I will make it different. This is a 48 and this is 18. This I will write 18 because I want that. This is 6. Okay, total you can write it, no problem. Okay, this is your answer, that is your 66. Total is 66, and now I made it a one rectangle and triangle. Therefore this is 6 and this is 60. right? Now you got a distribution diagram. Now we need to calculate p values. Therefore this is a p value minus p, this is a p2, and this is a positive p3, and this is a positive p4. Okay, now you can calculate that p1 is equal to half into minus 36 into 2 meter, right? Half into minus 36 into 2 meter. Therefore minus 36 p1, and z1 is equal to what? There only I will write it. Okay, z1 is from this height to this height. Okay, that is one third of, it is gone, that is one third of 2 meter and 6 meter. Okay, therefore it is 6 minus one third of 2 meter, that is 2/3. 6 minus answer, that is 5.33. 5.33. p1 is over. Then come to p2. P2 is half into 18. No, this is 18. Half into 18 into 1. Half into 18 into 1. That is a 9. p2. Then z2 will be equal to, from where? From this height to this height. That is one third of 1 meter plus 3 meter. That is one third of 1 plus 3 meter, 3.33. Then p2 is over. Then p3 will be equal to, p3 we will make this rectangle. This rectangle is 6 into 3 meter, that is 6 into 3, 18. Then z3 will be equal to 3 by 2, 1.5 meter. Okay, then p4 will be equal to the triangle, half into 60 into 3. Okay, so 60, 30, 90. Okay, then you got a p4. Then z4 will be equal to one third of 3, 1 meter. Then you calculate p, that is sum of all p's, and z bar equal to p1 z1 plus p2 z2 plus p3 z3 divided by p1 plus p2 plus p3. Okay, that is your answer. Thank you. We have another problem here, that is the retaining wall 4 meter high supports a backfill C equal to 20, gamma this much, horizontal top flushes with the top of the wall, means it is a horizontal. Backfill carries a surcharge this much, and if the wall is pushed towards the backfill means passive case. Compute the total pressure on the wall and its application. Okay, now look at this. The wall height is how much? A 4 meter. The wall height is a 4 meter, right? Yes, this is a 4 meter, and c equal to 20. C equal to 20. Gamma means density is also 20. Density is a 20. Then what? Surcharge is given 20. Surcharge is also a 20. Okay. Now I will take a reference point A and reference point B. But actually I told you that this reference point will be at this level and this reference point is here. Right? Now what is the formula? Sigma H at A is equal to sigma V tan square alpha minus 2C plus 2C tan alpha. Then alpha equal to what? Alpha equal to 45 plus 5 by 2. Is there any information for 5? That nothing is given, therefore I will consider phi equal to 0. Okay, let us consider this is a pure cohesive case, therefore the phi equal to 0, alpha equal to 45. It's not always that sigma V then tan square. Okay, will give, so that you can enjoy the problem. Then we'll give a problem that 5 equal to 30 degree, we'll give it. Then this is a 30 by 2, therefore 45 plus 15 is a 60, alpha is 60, therefore it is a tan square 60. I will write it. What is the sigma V at A? when you consider this point, I told you that you have to consider here at this point you got a vertical stress at 20. Okay, you got vertical stress 20 plus 0 is because of soil, then this is a tan square 60 plus 2 C is a 20 and tan square 60. This is your answer at sigma h a. Okay, what is that? The answer is 129.28 kilonewton per meter square. Okay, then over sigma h at b. Okay, I will draw that 129. That is a positive because passive it is. This is a 129.28. This is my reference line. Let it be a dotted line. Now at the bottom how much it is? Bottom I want to calculate, therefore that is sigma v tan square alpha plus 2c tan alpha. That is sigma v bottom is q is also there plus gamma h and tan square alpha plus 2c tan alpha. That is your q is a 20 plus gamma is a 20, height is a 4, then tan square 60 plus 2 into 20 into tan 60. The answer I got here is 369.28. That is the total answer. This I got, the total is 369.28. Means this rectangle, if I consider it as a 129.28, then that is 129 minus 129.28, then I will get 240. It is 240. However, problem is solved. Now you calculate this as a P1 and this as a P2. Then P1 equal to rectangle, it is 129.28 into 4. That is 129.28 into 4. 517.12. Z1 is from here to here. That is a 2 meter. 2 meter over. P2 is equal to half into 240 into 2 meter, 4 meter. That is 200 2 2s are 240 become 480. Then Z2 will be equal to 1/3 of 4. 1/3 of 4. That is 4 by 3 is 1.33. That is 1.33. Calculate total P, P1 plus P2, Z bar, P1 Z1 plus P2 Z2 by P1 plus P2. The problem is solved. Right? Over.